Number 5 is f of x equals log base 2 of x minus 1. Again, on a drawer, so I'm going to come over here and I'm going to sketch my original. I know I have my original asymptote is at x equals 0. Goes through the ordered pair 1, 0. So there's my original. Looking at my function, I only have a horizontal shift. So my graph shifts right 1. Shifts right 1. So that means my asymptote shifts right 1, my graph shifts right 1. So my asymptote normally is at x equals 0. So it has shifted over to x equals 1. My x-intercept is usually at 1, 0, so it also shifts over 1. And then I'm just going to swoop my graph like I've been doing. So there's the graph. Looks identical. It has just shifted to the right 1. So the domain is as far left as I can go, which is at positive 1. So the domain is 1 to positive infinity. The range is negative infinity to positive infinity. The asymptote of a logarithmic function is always x equals something. In this case, it's x equals 1. My end behavior as x approaches as far left as I can go. What's my y doing? So my graph can go as far left and then it goes down forever. So as far left as I can go is x equals 1. So as x is approaching the asymptote, 1, f of x is going down. So f of x is approaching negative infinity. Go the other way now. As x is approaching positive infinity, y is ever so slightly going up, but it is going up forever. So as x is approaching positive infinity, f of x is also approaching positive infinity. The graph is increasing from left to right. All right, on number 6. Look at your base on number 6. This is an exponential function, but the base is a fraction. It is between 1 and 0. If you'll remember from back a couple of weeks ago when we talked about growth and decay, if my base is a fraction smaller than 1, then I have a decay. Remember, that means your graph looks like this. The original starts and swoops up. Well, a decay swoops down. Okay? So, when I see a fractional base, I know that instead of me having my original, then I have a decay, which means I have a reflection across my y-axis. This is not the original. That base, being a fraction, takes that original and reflects it across the y-axis. So I have a reflection across the y-axis. I have a horizontal reflection. It reflects across the y-axis. This up in the exponent, that is a horizontal shift, going the opposite of what I think. So I shift right 1 and down 2. Because that minus 2, that does vertically, and it does exactly what it says it does. If it's up in the function, up in that exponent, it moves the opposite of what we think it does. So it says minus 1. Normally we would think it would move left 1. Well, here it's going to shift to the right 1. And I didn't put shifts right 1, but we need to say that. It shifts to the right 1. Make sure you tell me which way it shifts. It shifts to the right 1 and down 2. So I'm going to take this graph. I've already reflected it because I saw that base, so I know I start with an exponential decay. And that graph is going to shift down 2. So I'm going to go ahead and come down here and I'm going to draw my asymptote. My original asymptote was at y equals 0. Well, it's going to shift down 2. So now my asymptote is at y equals negative 2. Right here, so, and I know my y-intercept is 1 point above that. That's normally my x-axis, so everything shifted down 2. My y-intercept is 1 point above that. It's going to shift to the right 1. I'm still going to swoop down. So I still have that look. It's just shifted down and over a little bit. So my domain of this exponential function, what's the domain of any exponential function? It's all real numbers. What's the range? The range is that lowest y value, not included, up to the highest y value, so the asymptote up to infinity, so negative 2 up to infinity. The asymptote of an exponential function is always y equals something. Y equals that lowest y value where I'm trying to get, but I will never get. That y will never be negative 2, so my asymptote is at y equals negative 2. My end behavior, as x approaches as far left as I can go, so as x approaches negative infinity, f of x is going up. So f of x approaches positive infinity. Go the other way. As x is approaching positive infinity, f of x is trying to go down, but it can only go down to negative 2, and it actually will never get there. It is approaching negative 2. It will never cross that asymptote. So as x is approaching positive infinity, f of x is approaching negative 2. And this graph is decreasing.